is a pretty late night workshop, so I'm not really expecting anybody to be super formal. My little stuffed elephant is going to come along for the ride. After the workshop's done, we're going to be sticking around for about 15 to 30 minutes to answer any last minute questions you guys have about GraphQL. So yeah, this is a again, it's a hackathon workshop. Feel free to strike conversation with our mentors or anybody else. Yeah, obviously I'll reiterate on all of that beforehand. But how's everybody doing? Y'all psyched? Heck yeah. GraphQL is an awesome technology. I'm glad you guys are super interested in it. Yeah. So obviously, this is again a pretty code first workshop. So make sure you have all the pre-flight checklist all completed, and yeah, we should be good to go. I'm just going to test out my AV real quick. So yeah, I'm going to go ahead and share my screen. Can somebody let me know if it is working or not? Just in the chat is fine. Fantastic. All right, sweet. All right, just getting ready to start in just a couple minutes. Oh boy. Yeah, sorry about that. Computer lag. Yeah, all right. Let me just share my screen. I guess we're good to go. It is about 9 p.m. And yeah, let's get started, everybody. All right, fantastic. Yeah, one last AV check. Can everybody see my screen? Hey, fantastic. Okay, we're finally ready to begin, computer bugs aside. Hello, Hack the North, and welcome to the very last of the backend series of talks, Intro to GraphQL. I am so excited to meet all of you later on and throughout the rest of our question breaks. I hope that all of you had a lot of fun on the second day of Gear Up. I know that I did. There were a lot of really, really great sponsor demos. Let's get right into it. Just a side note, online workshops usually have a lot of latecomers, so we'll be starting off a little bit slowly and picking up speed closer to the middle of the workshop. This workshop is also incredibly code-based, so I tried to keep the slides as minimal as possible and make sure to follow along wherever you can. The best way of learning is purely by doing. Also, think of this workshop less as a place for me to lecture you and purely talk into a camera for an hour on end, and more as a place for you to vibe out, meet some amazing new people, and hopefully even learn something new. Feel free to strike up conversation with our amazing mentors, Eamon and Nicholas. You can see their blurbs in the chat right now. So yeah, we'll be spending an hour and a half together, which is a crazy amount of time by any means. But more importantly, we're going to be spending it together with some of the most awesome people in the world right now. And that being said, feel free to sit back, relax, get your code editor open, and get ready to start exploring the wonderful world of GraphQL. But before we get started, I'm sure you'll probably want to know a little bit about who's going to be guiding you through all this for the next 90 minutes. I guess it's time for me to say a little bit more about myself. You guys already know my name. I'm Rishi Kotari. I am a sophomore at Turner Fed Secondary School in the IB program. I'm 15 years old, and this is my third year going to Hack the North. I've been going ever since I was 12, and it's always been a crazy, crazy cool experience. I am in love with TypeScript, Formula One, GitHub, and a whole bunch of other really cool technologies. And if you're interested in any of those, I'd love to get to know you. Feel free to hit me a DM on Hopin or Discord. And I've been using GraphQL for a pretty long time now. And I actually got my start in a workshop not unlike the one that you guys are in right now. And throughout my years using it, I've been able to write everything from distributed networks to virtual currency, implementing it and using it in languages ranging from Rust and TypeScript to JavaScript and Swift and Golang. And I couldn't possibly be more excited to share my awesome experiences in this field with everyone here today. And speaking of social stuff, you can find me on the web and most other social media platforms at Rishiosor, right? Feel free to check out my GitHub, my Twitter, or on Instagram and my website at rishi.cx. Anyways, let's break down our timeline a little bit more today. The first thing we'll do is, really dig deep into the ideas behind GraphQL and, maybe even chat about it a little bit differently. We'll talk about the specific problems that it solves, how it works, the type system that it brings along with it, and really just holistically analyzing the concept as a whole. And when we've gone through all these analogies and really understand what the heck GraphQL is, we'll start applying those concepts by writing out queries and learning about introspection with a real-world GraphQL API. It was built purposely for this workshop. And after we sort of skimmed the surface of that and made sure that everybody has a really solid understanding of how to use GraphQL, we'll be going in the opposite direction, lower level. We'll be heading into the architectural side of things with the last part of the workshop, where we'll actually be building our very first GraphQL server and API using the Apollo and Type GraphQL frameworks. Like I said before, this is going to be an extremely code-first workshop. I've tried to simplify a lot of it, so anyone with prior experience using statically typed languages should be just fine. If you use Java or Swift or pretty much any other high-level language, most of this is going to come second nature to you. If you have experience with the Node or TypeScript ecosystems, it's even better. You already have a head start. You should already have the starter repository cloned onto your machine. The GitHub URL was given in your hack pack, and I sent it off in the chat as well. If you don't have Node and Yarn installed already, feel free to do that right now. And that's pretty much it. Let's get going. So, GraphQL might really seem like nothing more than just another buzzword or a new hype item for the tech community and web backend developers that really like to nerd out about random things. But I'm here today to tell you why it's the exact opposite. And this first section is really going to focus on the question that we're all really interested in. What in the world even is GraphQL? BS and hype aside, I'm super psyched that all of you guys are here today. GraphQL is one of my favorite technologies. Let's dive right in. In essence, GraphQL is a new paradigm for fetching data and interacting with APIs over the internet. You can think of it like the better, more structured version of REST. It allows us to specifically define what data we want to grab from our API. Gone are the days of underfetching or overfetching, trying to guess what your different clients are going to be using and having to rewrite your different queries for a bunch of different endpoints. GraphQL also allows us to establish strict type guarantees. The fact that we can specifically define what data we want to grab is purely a function of the fact that GraphQL allows us to write out really strong type patterns written in something called a schema definition language. We'll get into that later on. Finally, GraphQL allows us to establish some really high-level constructs for wrapping all of our different queries and building really more efficient interactions, like macro support in the form of GraphQL fragments. Now, if you're anything like me, that summary meant pretty much nothing. It is probably just a bit of mumbo jumbo, right? It's really high level for now. And so instead of thinking of ourselves as developers, let's try to think of ourselves as something a little bit more friendly. To better understand what GraphQL really is, we have to stray a little further away from the conventional ways we might think about things. Let's get away from the developer aspects of things, and let's think of ourselves as monkeys. Now, We all know that monkeys really, really, really like bananas. It is the one thing we've always seen in cartoons from like as a kid, right? And right now, we are all monkeys. Every single person in this call is a monkey, not a developer, not anybody even remotely related to GraphQL. And I don't know about you, but I don't have any I don't have any bananas around my room. And this poses a very specific problem. This is really big. We are hungry. It's 9 p.m. I still haven't had dinner. I want my bananas. And so, this is a big problem for me, right? I don't have any bananas right now and I need it. I need to be able to go get my bananas from some external source. And so, all of us here are at Hack the North. And so, I like to think that we are relatively smart monkeys. And so while our monkeys don't have any bananas right now, we are also really, really smart. We know where to find them. And this is a map that we've created in our head to sort of, plot all the different directions of things. The monkey emoji is our home base. It's our room right now. This is where we have to start and return. And the different bananas that you see, followed by the question mark, are the locations of the different banana trees where we can get these bananas from, right? In essence, the question goes from, where are my bananas to understanding how we can efficiently get all of these bananas from these remote locations. But there's a catch. We know where all of these different banana sources exist, but we don't know if they're actually edible or not. We have no clue whether or not the bananas we get back from these endpoints or banana trees are actually of the type that we want. Obviously, we only want to get back the ripe bananas that we can actually eat. When we go back to home base, we just want to get into bananas as quickly as possible because we're hungry. And so we have 3 trees. How do we go about actually efficiently getting bananas from them? So we might think for a while, maybe for a couple minutes, and we might have an interesting solution dawn upon us. The first thing is something like this. We start off at our home base, then we go over to the first banana tree, the one that's closest to us. We go over there and we grab every single banana that we can find, everything. There's no sorting, there's no, validation, nothing to think about. We just get every single bit of data from that one specific endpoint. We put it up around our arms and we head back home and deposit it there into, maybe a little store or a safe that we have. And we repeat that for every single banana tree that's out there. And, this is, this might seem really good as, we're getting a lot of bits of data at once. We have all the different kinds of bananas that we could possibly want, right? But when you think of it a little bit deeper, there are actually a lot of problems with this. And there are simultaneously a lot of optimizations that can be made here. Obviously, we are not here to eat rotten fruit. We're not here to eat unripe bananas, right? We're here because we're hungry and we want to get bananas that we can actually eat. And so we need a way to select only the non-rotten fruits. In selecting every single banana that are on every single one of those trees, we get a lot of bananas that we don't even need. And so at home, we have we have this enormous pile of bananas, but now we need to sort all of them in the wrong place. I don't know about you, but I would not want rotten bananas all over my room, right? It's the wrong place to do it. And we're sort of offloading this problem into the wrong place. How might we fix the way that we go through all these different banana trees to make everything smoother and end up with only the bananas that we want? It's also worth noting that the strategy that we just used essentially makes sure that we use as many trips as possible. 2 for each, 2 times 3 means that we're making 6 trips in total. And again, I don't know about you, but that is a lot of walking. And I don't want to walk that much for my bananas. And so we might think about it a little bit more. And then another monkey, maybe from some place like Facebook, might give us a paper or a document saying, hey, here's a new strategy that you can use. Why don't you go out and test it? And so this is what that strategy kind of looks like. We start off at home base again, but then instead of going to every single one of these trees, we only head on over to the first banana tree. And then under one arm, we go and grab all the different bananas that we can eat, right? All the different purely ripe bananas, right? We grab all the yellow ones, put it under our arm, and we head back over to the next banana tree. We repeat the process for every single one, and we can head back home. And what happens next? Well, the optimizations and the problems that we saw in the last strategy that we used have all essentially been solved. Now we shorten the amount of trips that we had from 6 trips all the way down to 4, and the bananas that we have all the way back at home are guaranteed to be ones that we can actually eat. Because on the actual banana trees, that's where the sorting occurred. The only bananas that we have at home are now ones that we can actually eat and consume, as soon as we get it back. We've essentially just selected the bananas that we actually want and that are of the type that we actually need. So monkeys are excellent. I think that they are really neat animals, but what in the world does this have, what do they have to do with GraphQL and REST? Well, they actually have more in common than you might think. REST principles are kind of like the first strategy that we used. If you replace the monkey with a computer or a client that needs to fetch some outside data, and the banana trees with some servers or APIs that can return that data, REST is what the first strategy looks like. In essence, it says, hey, we have all of these different banana trees and servers. You have to go out and individually fetch all of the data from every single endpoint. There is client-side validation, which is, in my opinion, the wrong place to do all that sort of stuff. And this leads to a lot of useless runs. When you have to individually fetch every single endpoint, you're losing out on any of that concurrent timing, right? It also means that you have to make sure that all of your different types and all the data that you get is of the form that you want, or you might have to coalesce it on the client side, right? And in general, this is a bad principle to follow, right? You want your client to be as lightweight as possible. Any heavy computation isn't really going to lead to a very high performing product. On the other hand, the second strategy that our monkeys followed is really more resemblant of GraphQL. Instead of having to go out and individually fetch every single endpoint, GraphQL allows us to do all of our different querying in one round trip. That means that there's only one request for every single bit of data that we ever want to get. GraphQL also has on-the-fly type validation. All of these difficult, computationally complex problems are now all offloaded to the server, so that as soon as we get the data back from our API, we can be completely 100% sure that it's of the type that we want and of the scalability and all the different shapes that we need. There's rotten banana checking built right in. And also because GraphQL condenses all of these different fetches into just one single one, there are less overall trips. There's much less room to go wrong, right? And so, bananas and monkeys are really fun, but we're here to get into actual programming, right? We're here to look at text, and we're here to look at, really colorful little IDEs, not just grab bananas efficiently. And so, let's break this down into what GraphQL really is. We know some of the problems that it solves, but we don't really know what the technology is in and of itself. GraphQL is built up of two really big principles: the schema definition language and the server specification. The schema definition language is really the thing that we usually talk about when we refer to GraphQL. It's a domain-specific language that we can use to both define types on the server side and interact with the API on the client side. You can think of the GraphQL schema definition language kind of like the SQL language. SQL is a technology that not only allows us to strictly define the structure of the data on our database, but it defines what interactions we can use with that database. What fields and rows we can select, what tables exist, what types exist, and so forth. GraphQL is the API equivalent of that. The schema definition language, when put on the server, allows us to define the shape of all of the JSON that we can possibly return. You can think of it like the same way that a REST API might return a really big JSON file. If you translated that into more general code and then transferred it into types, you would have a schema definition language file. And that essentially describes all the possible types for a GraphQL API and all the possible queries and mutations that you can run on it. Now, the schema definition language is really cool, but let's try diving into actual code examples. What does it really look like? Well, I said that one core part of the schema definition language was the fact that you can really describe your data. And this is what a server-side schema definition might look like. We have a bunch of different types, and starting from the bottom up, we can see all the different things that our user is able to do. Don't worry if you don't understand this at all. that's all of that is coming up in the next section. But just at a glance, we can see that the server-side specification has a bunch of different type definitions, and essentially these types hold a bunch of different data. In this case, there's a special kind of type called query, which seems to have these cool little functions and fields that happen to return some other types, right? And this is what's known as the query type. Obviously, its name is just query, but it serves a very specific purpose. That holds all the possible queries that we can possibly write as a client. Speaking of clients, what does the opposite side of the schema definition language look like? It's cool that we can define the shape of all of our data, but if there's no, how might we actually interact with it? Well, we're going to have to write in, schema definition language programs for that as well. On the opposite side of things, when we actually want to get data out of an API, we can go ahead and write a specific kind of schema definition language program. In this case, this is called a query. We'll get into what these different keywords mean in the next couple slides. But this for now, you can think of a query just as a list of different properties that you want. In this case, it's very declarative. We can literally see that we're getting to-dos, and then the to-dos query returns a type on which we can query the data property, and then on there we can select the ID and the title fields. It is pretty much exactly like SQL, just with a little bit more curly braces. Now, I keep talking about types a lot. What do they actually mean? Well, you can think of types in GraphQL kind of like structures in high-level languages. These make up the really core part of the schema definition language and are composed of two different kinds of types: object types and scalar types. Scalar types are primitive JSON serializable data objects. You can think of them like primitive types from other languages, things like floats, integers, strings, and so on. GraphQL also has a special kind of scalar type called an ID, which is basically just a string, but represents it a little bit differently. Object types are equivalent to structures, or in some other cases, interfaces or protocols. And in this case, they have different fields on them and are composed of different record types. An object type is literally just an object that's composed of different fields. And these fields all have a name and a corresponding type. In this case, we can see that this type, which is called to-do, has an ID field, which obviously has an ID type. It also has a title field, which has a string type, and a completed field, which has a Boolean type, and a user field, which has a user type. And it's worth noting that types can be recursive, types can be as hierarchical as you want. In this case, we're actually using an object type here within another object type. It works exactly the same way that typing and class annotations work in a bunch of other languages. Now, all of this is still super high level. Don't worry if you don't understand it right now, but those are just the really basic aspects of the schema definition language. Let's delve into actually interacting with it a little bit more. We touched on this a little bit more in the client side part of things. When we actually need to interact with GraphQL, we have to write things known as queries or mutations with the client side schema definition language. In the same way that you might write a GET request in the REST equivalent of things, you need to write a query in GraphQL to get data out of the API without any side effects. It is purely a read operation. Sometimes, though, you might want to mutate the data on the backend. In REST, whenever you want to make any updates to the backend, you might write a post or a put request, or even an update one if you're weird. The equivalent of this in GraphQL terms is known as a mutation, because it accepts an argument, and you can also query on the parameters that come afterwards. You are literally mutating the data on the backend. Now, we have a pretty high level understanding of what the schema definition language is, but this isn't all that GraphQL really does. And we know all about the language side of GraphQL. Where does all of this actually come into play? Parsers and compilers for GraphQL don't just magically turn into JSON. They have to be fed into a specific kind of API, one that implements the GraphQL server specification. This is a really long document made by the GraphQL consortium, which you can think of as this high-level entity that is tasked with kind of controlling the way that GraphQL moves. And you have to implement this specification to serve up GraphQL APIs. You have to implement it to make your GraphQL API come to life. It's just a document that defines how GraphQL is parsed, queries resolved, types annotated, and so forth, right? Don't actually worry about, truly understanding what this means. We won't really be touching too much into it, unless, of course, you're one of those low-level developers that really likes to get your hands into everything. Most libraries for GraphQL and the ones that we'll be using actually come with a full-on server specification implementation. So you're almost never going to need to touch this document. Now, we've talked about monkeys, we've talked about bananas, we've talked about schema definition languages and a whole new different subset of tools, but we haven't touched on one of the most important attributes of GraphQL. Why in the world should you use it, right? This is probably the most important part of this entire workshop, right? Because now that we know what problems it solves, we can actually start to understand what the motivations behind it were. And to best explain this, we should actually start delving into code a little bit more. This is a pretty classic example. We just need to go ahead and fetch some data from a couple of different endpoints, right? In this case, our task here is to get all the different statuses, the IDs, and the types of all of the upcoming capsules from SpaceX launches, right? The SpaceX community has defined a pretty cool little API for it. On the left, you can see the REST equivalent of things. It is pretty simple. It just fetches an endpoint, it transposes that into JSON, then it logs it to the console. And on the right, this is the GraphQL equivalent of it. It's way more declarative, but you might think that it's a little bit more complex too. We're not just getting a GET request anymore. We're sending a POST request along with a body and a stringified query string. But you don't need to worry about any of that. That's not the purpose of what we're doing here. But apart from that, everything else is purely the same. And the GraphQL thing might seem a little bit more verbose right now, but keep in mind something very important. Something's about to happen, and keep in mind, this sort of big diagram of things. I'm about to change slides, and keep, just have this image in your mind as we're about to. Did you catch that? Well, okay, let's compare what happened now with what happened a little bit before. Over on the left, when we need to start to grab more and more data, in this case, our task has changed from just getting the statuses, the IDs, and the types from upcoming capsules to the statuses, IDs, and types of all the current capsules and any of the cores that are associated with them at this current moment. On the left, we had to rewrite our entire algorithm to account for fetching from different APIs or from different API endpoints. Sorry, we had to map over all of them and execute them concurrently using Node's Promise API. We had to rewrite our entire algorithm to make sure that we can deliver all this as efficiently as possible. But on the right, we only had to change around the query string, and that's it. We didn't have to do any fancy pants algorithmic work. We just had to add it. We just had to add a couple more properties to our query, and that's the magic of GraphQL. Whenever you want more data, the fact that your entire backend is coalesced into one specific place, ready to be queried at any possible time, it means that requesting data is just as easy as adding another line of code. Now, that was a lot of stuff to be thrown at you, and so let's recap a little bit before we head into our first question break. And we have a couple minutes left, and we're running a little bit earlier. So we talked about the specific problems that GraphQL solves, why it is so much better than REST in specific cases, a little bit about the underlying architecture, as well as the type system that it brings along with it. Don't worry if any of this seems really high level. We're going to be really getting into the nitty gritty of things in this next section. And so that being said, I'd love to answer some of your questions that you have right now. I'm sure that you have a lot. So I'm going to go ahead and stop sharing my screen. And let's take a look. Okay. Do we happen to have any aggregated questions that are important for the entire workshop to know? Let's see. Thank you, Jackie. I mean, your Docker workshop was excellent. Really like the IKEA example. Are there any scenarios where using GraphQL is a bad idea? Yes. A lot of people will say that GraphQL is like this one sword that can kill every monster, but it really isn't. Whenever you have something that's really, really small, whenever you have something like a REST API that maybe has like one or two endpoints, you aren't going to get any form of benefit out of GraphQL because all the different boilerplate that you have to add, queries that you have to parse, all that doesn't really make sense for when you only really have two different queries. And in that case, your project is probably going to be small either way. GraphQL was originally designed for Facebook's platform, right? When they were rewriting their mobile application, a really big problem that they were facing was the fact that their web platform was sort of being transposed onto mobile, and then their queries didn't work. It was all really janky. And so they wanted a way to dynamically request only the specific data that they needed. And because Facebook's newsfeed API is so massive, right, it makes sense. Oh, I think my camera just cut out. Give me a sec. And we're back. Yeah, technical difficulties happens to the best of us. But yeah, they have a massive API with all of this different data that they need to collect at any given point. When you have really, really big APIs that are really obtuse and verbose to collect into one specific query, that's when GraphQL can really shine. When you have something that is just as simple as like a one endpoint thing, you aren't really going to see any benefits out of GraphQL. With the backwards Mercedes hat and AirPods Pro. Okay, for the record, okay, Christian, we're about to get into that in the next section. We're actually going to be writing our first queries ourselves. For the record, this Mercedes hat and the AirPods Pro were gifts. Okay, I don't like to splurge on things. But yeah, are there any other questions? Is GraphQL cross-platform? Yes, GraphQL is actually just a it communicates over HTTP the exact same way that REST would work as well. You can query it using any form of device that has support for the internet. So yeah, Android, iOS, web, whatever you want. Yeah. Any other questions, guys? Let's take a look. All right. Okay. So I'm going to go ahead and assume that everybody's good. Time to get into the next section. And this is our very first interactive one. So get ready to get your fingers sort of worked out, I guess. We're about to do a lot of typing. Yeah, more info on how to keep a query type safe. That's what we're getting into with this next section. All right, about to share my screen again. Once again, can you guys see my shared screen? Is it doing the cool recursive thing? Fantastic. Let's head back and we're good to go. Okay, so this is where we're going to get to see the real use of GraphQL. We're going to talk about all the different techniques that we can use to really start to study APIs and get to know this type system really, really well. But more importantly, we're actually going to be using GraphQL ourselves. We're going to be using an API. And so let's get started. This is the website that we're going to be using for today's workshop. It is purpose built for this. It's literally just a sort of a mock data API. It's just a minimal hello world one. So I'm going to switch over to that right now. Feel free to type in g.rishi.cx. Shout out to Pork Bun for the amazing domain. Feel free to head on over there right now if you want to follow along with all the different queries. So I'm going to head over there to give you a really quick, high-level demo of what this looks like. This is called Apollo Playground, and it's a pretty standard little platform for writing out GraphQL queries written in the schema definition language. This is where we're going to be getting to write client-side schema definitions, and actually generating and typing out the different programmatical queries and mutations right over here. Over on the left here, we have the first big box. This is just an editor for our queries. Over on the right over here, we have a docs tab, which is essentially just a parsed version of the server-side schema, which also has its own tab. Right, you can see all the different types that I was talking about right over here, and how they actually list out all the different data that we can possibly execute on. Right. So again, this is where we write our queries. If we hit the play button on any specific one, we'll get a JSON response right over there. And so that was a really high level understanding of what this of what Apollo Playground looks like. What does this API actually do? Well, like I said before, it is essentially just a mock data thing. It has a bunch of really cool models that we can query on, stuff that you'll probably encounter in your daily life, stuff like comments, to-dos, posts, and everything. In this case, to-dos looks interesting. So let's set our goal for this initial query to be to write a query that gives us back all of our different to-dos and maybe one property associated with them. Let's say the ID. That's going to be our goal. Get back all the different to-dos in one specific query and get the IDs that are associated with that and nothing else. And so, let's walk ourselves through what the process and what we should actually do to make this query come to life. But before that, let's define introspection. It's often useful to ask a GraphQL schema for information about what queries it supports. Whenever you're first dealing with an API, you want to be able to really understand what to do with it. That's where documentation comes into play, and that's why it's so important for REST, right? Because that's oftentimes the only tutorial that new users are going to be able to get when they first view your API. But because GraphQL is self-documenting, it has this incredibly rigorous type system, it allows us to do this not just through documentation, externally, but also internally using the introspection system. And this can be done using some special queries that we can run, but we can also ask the schema purely for supported queries by literally just taking a look at the documentation tab that I showed you guys earlier on the page of the Apollo Playground. In this workshop, we'll be focusing on that second kind of these two different methods for interacting with the API. Purely both for the sake of time, but also because nobody really uses the more verbose introspection kind of things. I want to be leaving you guys with actual production practices. And so let's continue on. This is the big question behind GraphQL. What do you want? GraphQL's big value proposition comes from the fact that you always need to specify what you want to do at every point in time. And so whenever you make an interaction with GraphQL, you should always ask yourself this, whether that be, asking yourself, what do I want out of this API? What do I want this API to do if you're ending up actually building a GraphQL one? And so, we've already defined what we want to do with this interaction. We want to get back all the different to-dos and their associated IDs. And so oftentimes, you can't really answer this question until you actually know what you can do. And that's where introspection is great. When you start to study an API using introspection techniques, you can start to understand what you can do with that API. And then eventually, you can start to narrow things down and understand what you want to do. And so, that is kind of the really big different thing. And so when you finally solidified your understanding of what you want your interaction to do, you can actually go ahead and start building it. You have to first ask yourself whether or not, or what type of interaction this is going to be, whether it's a query or a mutation. Think about it. Does reading out a bunch of different to-dos require us to mutate data on the back end? Probably not. We don't want to change around our to-dos. We just want to read it. And so in this case, we can answer this for ourselves and say, we don't need to mutate any data. So we're going to use a query in this case. And we also need to think of all the different possible types that are needed. In our case, we just want to query on the IDs or on the IDs of every single one of these to-dos. And so that's it. And now, we have a really great understanding of what we specifically want out of this interaction. And so we can start to build out our query. You should have g.rishi.cx open on your computer at, probably in split screen so that you can see both Hopin and your different query builder all at the same time. And, feel free to follow along. If you don't want to, walk yourself through it, that's totally okay. Feel free to follow along on my screen share right now. This next bit is going to be a mixture of actual live coding in the GraphQL playground and me speaking about all the different features that are associated with it. I'll be walking us through the process of introspecting an API and studying types on the playground. But we'll be constructing the queries, all together. And so hopefully you guys are ready. Let's get started. Before we do so, I'd actually like to, take like 10 seconds out to see if anybody else has has any questions about Apollo Playground. All right, I'd say not. And yeah, let's head back over. So the first part of any real GraphQL API interaction is the layout component of it. The first thing that you need to tell the GraphQL API is that you're gonna start to write an actual query, right? And so the first thing that you should write is literally just the keyword query. You can use tab for auto completion. We can use the query keyword to tell the GraphQL API that we're going to be not only writing the query, but that we only want to extract data out of it. There are a couple more keywords like this, like mutation and subscription in some cases. And so after you've told the API what you're going to be writing, you also need a name that's associated with it. In this case, because we're writing out a query for to-dos, we can literally just name this to-dos. And so after we run this, this isn't actually going to build. We can click on to-dos because there's another thing over here, but we see a red line. That shows us that there's an error there. And so right after we do this, we need to open a pair of curly braces. These braces they always signify a new code block and can have different pieces of data in between them, depending on the actual type that we're looking at. In this case, because it's a top level thing, we have to work with a query to get data out of the API. And so in between these two curly braces, the only thing that we could possibly do is write properties that we want to get out of it. Everything in GraphQL is about writing out just a list of properties. And in queries and mutations, that's everything that you can write in between these two curly braces. Because of GraphQL's type system, the specific properties that we're trying to get have to correspond with the types and objects that are laid out in the server-side specification. At this top level, we can start to understand what queries or what properties we can write in between these two curly braces by clicking on the docs tab. I already had it open, but as soon as we see this, we can see all the different properties that we could possibly write between these two, right? Because we're writing a query, we can take a look at the query section. And so we see that to-dos might be the thing that we're looking for. We want to get every single possible to-do out there. And so we can go ahead and type in to-dos. So you might think that this works, right? We just want to get a list of all of the different possible to-dos. But in fact, this is actually going to throw an error. It says that field to-dos has to have a selection of subfields. And so why is this actually happening? This is purely because GraphQL sees this as an incomplete query. Again, GraphQL's main value proposition comes from the fact that you need to specify verbosely every single bit of data that you want. And so by extension, you need to query down all the way to scalar properties. GraphQL is never going to give you any more data than you specifically request. In this case, it doesn't know, what properties of every single to-do that you want. Do you want the user attribute? Do you want the ID? Do you want, maybe the completion status? We only want the ID. And so cleverly, it throws us an error saying, hey, you've given me, this really big query, but I have literally no clue what you want me to do with it. You have to keep on specifying down all the way to scalar values, my guy. And so, from here, we can see that we have to open another curly brace pair. Remember, curly braces are essentially where you can write out the list of properties of the associated types of them. And so we have to use introspection to define what properties we have to write between this next pair of curly braces. We can click on docs and see that our intuition was correct. Remember, GraphQL queries and any form of GraphQL interaction always needs us to have at least one property that returns a scalar value, right? Because that's the lowest that you can possibly go, right? In the big tree of queries that you write, a scalar value is the one value that will never change. It doesn't have anything below it. And so when we click on to-dos, we can see that to-dos doesn't actually return a scalar value, it returns an object type. Remember, object types are things that have different fields associated with them. And so in this case, we can see that there are three possible properties that we can put in between these two curly braces, right? The associated type is the return type of to-dos, which is called to-dos page. If we type in data, and we try running this, surprisingly, we get the exact same error. And this is kind of confusing, right? You might think that, you can only nest things once, right? And so data must return a scalar value, right? Well, no, because GraphQL's type system is so powerful, you can actually nest as many object types as you want, right? You can even do things recursively. So you can go down all the way to infinity. But, we're not trying to do that right now. That's a story for another day. So we have to, cleverly, we have to open up another pair of braces, because data doesn't return a scalar type. It returns an object type. in this case, it returns an array of to-dos, which we can see right over here. So now, the only possible properties that we can write in between these two, pairs of curly braces have to correspond with the properties of to-do, right? And we can see over here that there are 4 possibilities, right? Since we only want the ID, we can go ahead and type in ID from the property right over here. And so, when we run it, we don't see any more errors, and we actually get the query that we want with the, with specifically the data that we need, right? We asked ourselves at the very beginning of all of this that we wanted to write a query that gives us back all the different possible to-dos, all the data associated with it, but specifically only the ID of every single to-do. And we've done it. GraphQL has given us back the data in the shape that we needed, and the shape that we actually defined in the schema definition language program. And it's only given us back all the different IDs. Now, this is commendable in and of its own right. A couple minutes ago, you actually didn't know anything about what this was going to do. And so right now, you've just written your very first schema definition language program, right? So if you haven't done so already, give yourself a pat on the back, or if that's not your style, feel free to just smile. But, we're about to do something a little bit more interesting. Like I've been guiding everybody through this pretty slowly, so that we can all get a feel for how queries are written. But now that we've gotten the gist, let's pick up the pace. Obviously, to-dos aren't the only type of object that we can query on our API. We can clearly see that, from the docs section, there are a bunch of different types that we can query, right? And so I'm going to leave you guys sort of in the dark here, pun not intended. And so in essence, here's your first challenge. You're going to be, I've walked you through how we might query, all the different to-dos with all of their different IDs. I'm going to ask you to make another query. Feel free to, delete all the different text that we have right here. You can copy it in later. But right now, you should create another query called posts that should give you back all of the different posts that are associated with, with this API, and specifically get back all the different IDs. And we'll go along from there. I'll give you about 2 minutes to do so. And that is your first challenge of today. All right, so again, if you guys have any questions, feel free to put them in the chat. But right now we're not going to be doing anything. For you though, you need to make sure that you pretty much write another query conforming to the post protocol that gives you back all the different IDs of all the different posts. Yeah, that's actually just the limit of the mock data that we put into the database. No real reason other than that. Yeah, no worries. All right, how's everybody doing for this first query challenge? Did you guys manage to get all of the different post IDs? Fantastic. All right, let's head back into the workshop itself. Time to share my screen again. And there we go. All right, technical difficulties again. All right, let's head back to the API. So if you aren't done already, let's walk ourselves through what this might look like. The first really big thing, looks like my camera died again. No worries. The first big thing that you need to do, again, is lay out your query. In this case, because we're writing another query, and I asked you to name the posts, the initial sort of skeleton that we wrote should look like this. We have the 2 different double braces, right, which correspond to all the different properties that we can write in between them. To understand what properties and what words we can write, we have to take a look at the first layer of the docs tab. in this case, because we're trying to get some data out of posts, we can click on that. But because we're smart and we know that GraphQL won't run until we actually get down to scalar values, and post returns another object type called post page, we have to keep on looking down the introspection tree. And so, let's click on data because we're trying to get some data out of it. And only after we go down there do we see that post has a scalar ID or has a scalar value that we can actually query, right? And so we see this different tree and these different values that we have to query. And so we can start constructing things sort of like this. We have an initial name of posts because that's the top level structure that we're taking a look at. And then that returns something that implements post page. And so we have to open up another pair of curly braces. The properties that we can write in between here have to correspond with these two, right? And so in this case, because we're trying to query data, we can do that. Open another pair of curly braces, and then we can get down to scalar types, finally. And so when we write that, we are good to go, and our solution runs. But GraphQL is so much more powerful than that. What if we don't just want to interact with IDs? Well, the great thing is that we can write as many data properties between these curly brackets as we want. One of the really core principles is that you can do everything. You can get as much data as you want in one specific round trip. And so let's say that instead of just getting the ID, we want to get, I don't know, the title and maybe the body of every single post, right? We can see over here that these also correspond to scalar types. So we can just type in the keyword and we can be 100% sure that this is going to run. Oops, I typed in a slash there. We can type in title and body. And then as soon as we type in those those properties and we hit posts, we get back all the different data that we could possibly ask for. However, I haven't been entirely truthful with you from the very beginning. I've always sort of said that these different fields are static properties, right? But in GraphQL, oftentimes they aren't. Sometimes these specific fields can actually take in arguments. Sometimes you don't just want to augment the kind of data and the shape of it that you're getting back, but you also want to augment how that data is resolved. Maybe you want to specifically query just one object, not all of them, right? And so for that, you might want another type of query, right? And so let's start from the very beginning. Let's say that instead of getting all the different to-dos, we want to get just one. And let's pick a random ID here. We can see that all of them are numbers. Let's say that we want to query the to-do with ID 27. I don't know. So how might we go about doing this? Well, first off, let's clear out our entire editor just so that we can start from a clean slate. We can start off with that initial boilerplate before we get into actually writing out scalar property names. We can go ahead and type in query. And in this case, because we're querying one specific to-do,
in this video, we're going to look at
hit to-do, and then open another pair of curly braces because now we're starting to query these properties. We can go ahead and click on docs. And remember, last time we clicked on to-dos because we wanted to get a bunch of different to-dos, plural. In this case, because we just want to query one, we can go ahead and click on the singular to-do, right? In this case, we can see that to-do returns another object type. So we're going to need another pair of curly braces, but it also has something else that's a little bit more interesting. It has this arguments section, not just type details. What does that mean? Well, let's see, let's just type in to do and then, how we might do it regularly. If we type in to do and then have, just type in all of our different subfields, in this case, let's say that we're querying for IDs, our title, and maybe the completion status, right? If we do that, this isn't going to run because it says that an argument ID, like just from the error dashboard, of type ID is required, but it was not provided. This tells us that this query takes in a required argument parameter that's known as ID. How do we supply those? Well, we can actually use just regular parentheses. This is actually really resemblant of how we can define functions and their usages in other different languages, right? In this case, we can go ahead and use some parentheses to supply some arguments to this query, right? Arguments are always named in GraphQL, so they don't have any specific order. Usually, you'll just put it alphabetically. But in this case, because we need an argument that's required, that is specified by this little exclamation point, right? The exclamation point in any type signature essentially just says that it is non-nullable, right? Non-nullable just means that it can't be empty, right? We just tried running it in nullable mode, and it threw an error because it's required. It literally cannot be non-nullable. And so we can go ahead and type in ID, to say that we're specifying the value of the ID argument. And then because we know that ID, like the type, is just thin layer over strings, and that's what they're used for in in GraphQL queries, we can go ahead and type in something like 27. Remember, strings can only be on one line. I just hit enter there. And boom, we actually just supplied an argument to our query. This is awesome. Now we know how arguments work. And obviously, this data type can be anything that you want. It can be, a JSON or a JSON string. It can be a number, an integer, any primitive type whatsoever. And so, that is essentially how arguments work. But there's one last feature of GraphQL that you should really know about. I said before, like one of the first queries that we ran, was this to-dos one. So we don't really remember it right now, but just follow my lead. I'm going to be recreating that from scratch right in the query that we're doing right now. So just type in to-dos, your pair of curly braces, then data, another pair of curly braces, and then ID, title, and completed. Now, that last bit of typing in ID, title, and completed, that is, I don't know about you, but I feel like that is very tedious. When we have a bunch of different, queries that are all extracting properties out of the same type, remember, data returns an array of to-dos. So the only possible properties that we can write here have to be on the type called to-do. And we're using that exact same logic over here, when we're creating a single to-do. Right, the properties that can be between these curly braces have to conform to the properties that we listed on the to-do type. Whenever we find ourselves repeating these sorts of patterns, right, and whenever we feel like we might benefit from some form of data extraction, right, we can go ahead and write what's called a fragment. A fragment is essentially just a fragment of a query, right? It can be anything from a list of different properties to a full-on query itself. And so let's say we want to extract out these three properties. How do we go about doing that? Well, like the name parameter syntax for writing a query, we have to start out with a keyword. In this case, type in fragment. We can call our fragment something like f_to_do, and we have to specify what type we want this to be on. Remember, normally GraphQL can assume what type we're doing purely based off of the inference that it has from these curly braces. But because this fragment is all on its own, we have to explicitly specify that the properties that we want to write in this fragment have to be on, in this case, a to-do. Then we can open up a curly braces or a curly brace pair and then start to write in properties over there. In this case, we want to extract out the ID, the title, and the completion status of each. And then to actually use it, we can go ahead and use ... f_to_do, ... f_to_do. Sorry there, my keyboard was being a bit jittery. And so, don't worry about what this will actually do. In like about 10 seconds, we're going to see what this actually extracts out to. We can type in ... f_to_do yet again. And so when we hit play this time, just think in your mind about what's about to happen. We just extracted out a bunch of different fields from the to-do type and into a completely separate one. And now we've been reusing it yet again. When we hit play, this actually doesn't do anything too non-obtrusive on its own. It actually returns to us the exact same data and the exact same shape that we would have gotten if we had just included these properties on their own. Fragments are literally just expandable macros, and that is it. And so that is a really quick tour of the entire GraphQL client-side schema definition language. And again, feel free to give yourself a pat on the back because I could honestly just leave you right here, and you would be probably one of the best GraphQL developer or GraphQL developers that the world's ever seen, right? You now know pretty much everything to do with the schema definition language, and you know all the different intuition that's associated with it. And so it's time to head on over to our next question, or to our next question period, along with a recap. What have we done so far? Well, like I said before, we have done a crazy amount of stuff, and we've learned, a bunch of stuff in a pretty squished deadline. So far, we've learned about what GraphQL consists of, what the schema definition language looks like, and the two big different types, the differences between queries and mutations, what the Apollo GraphQL playground looks like, along with a construction of our own queries, and some of the different introspection techniques that are associated with them. And so, yeah, again, feel free to get up, stretch your legs a little bit, and yeah, let's see. If you guys have any other questions, feel free to put them in the chat. For my mentors, do you have any aggregated questions for me? What are you using to present? This is actually a custom built presentation software. It's based off of MDX Deck, which is an NPM package, like purely for building like really cool code-based presentations. Is there a way to flatten the ID objects into an array of IDs? Yeah, so that is like GraphQL won't actually do that stuff on your own. You can define the shape of your data, but you're going to have to map over all those different bits on your own client side. But that's a lot less computationally complex than having to go through the entire layer all on your own. But yeah, GraphQL itself doesn't have a specific data mapping strategy. Yeah. What's Apollo? Okay. Apollo is essentially just a it's a company that really specializes in GraphQL infrastructure for the Node ecosystem. Oh boy. For the Node ecosystem, in essence, it's kind of like an Apollo project for GraphQL. They make a bunch of different libraries for interacting with GraphQL and building out GraphQL APIs. Basically, they are sort of one of the first projects that kind of brings GraphQL back out into the mainstream. How do those queries and mutations look in code? Yeah, so usually you will just represent them as just strings and send them off in a post request to your GraphQL endpoint. But you can also use something called GraphQL tag to actually compile it client side and then send it over to your API. It doesn't there really isn't too much of a difference, but yeah, you can use them purely as strings. All right, any other questions? Yeah, no worries. And of course, all of this is completely available on all the different hackpack links that I've given. And yeah, if you ever feel like you need some more information, feel free to check out any of the supplementary documentation. All right, it looks like those are all the questions for now, at least. Let's head on over to the next big stage of our workshop. And just as a disclaimer, this is actually probably one of the really big code first pieces of this workshop. I kind of held your hand throughout the entire bit of actually defining a schema definition language, but this is going to really hinge on your understanding of TypeScript and GraphQL principles. But before we do that, let's actually take a look at what the architecture behind GraphQL looks like. We're about to head on over into our final section in actually building a GraphQL API. And yet again, we have to ask ourselves, what do we want this to do? Like I said before, this is the big question of GraphQL, and it will always crop up whenever you try to be a developer for this amazing technology, right? And so in this case, let's define what we want this API to do. I'm thinking that we can build some form of a to-do API, something that will allow us to view a bunch of different to-dos, maybe update them, toggle their completion, and maybe update a whole thing and create them. And so, your actual answer to what do we want this to do can be as vague as I want to build a to-do API to something as specific as mapping out, all the different queries and mutations that your API can support. And in this case, we're going to do something pretty specific. We can actually just map out all of the different queries and mutations. We want to build a CRU API, not CRUD, not create, read, and update, and delete. Just create, read, and update. And so for that, we're going to need two queries, which allow us to both get all and just get a single to do. Then we need two update mutations, which will allow us to both toggle an update or toggle a to do and complete, essentially just update a big to do in bulk. And then we need one create mutation, which will allow us to sort of create a to do. We'll also be walking ourselves through how mutations are actually used, along with other forms of arguments. Now let's head on into a demo of what this looks like. I have this running on a local server. We can go ahead and try to create a mutation. Don't worry about following along. I'm just here to sort of demonstrate what this stuff sort of looks like. All right, so in this case, we can see that all the different types and attributes work just as planned. We have our different mutations. This is what the docs page looks like, along with the server-side schema associated with it, obviously. We can see that we have all of our different mutations called create to do, update to do, and toggle to do, and all the different queries that are associated with it. Let's dive into how we can actually start building this. But before we do that, we have to start delving into what GraphQL actually looks like on the server side of things. What is the architecture of GraphQL itself? So now we're going to think of ourselves kind of as the GraphQL parser. We are right now an API trying to intercept a really complex query. How do we break this down and try to extract actual data out of it? Well, the first thing that we'll do is actually grab this entire query ourselves. We get this really complex little file, might be wrapped up in a bunch of different strings, right? What's the first thing that we do? Well, we have to desugar it, right? And what I mean by that is we have to expand out all of these different macros called fragments, right? And so we'll replace all of the different properties in every place that each fragment is used. And then what's next? We now have everything in one specific discrete query. The next thing that we'll do, and this is probably the final thing, is identify where actual object types are being returned and where scalar types are being returned. And so in this case, we can see that to-dos, this returns an object type. Data within it returns an object type, and only after we get into those can we find scalar types. And so in between all of these different things, each of these big object types are associated with their own resolver functions on the actual API, written in just plain code. Resolver functions are exactly what they sound like. They take in a bunch of different arguments, in this case, about the kind of object type that's being returned, and then it resolves data out of it. And so, don't worry about truly understanding what the specifics and semantics of that actually looks like, because we're going to be delving into how to build them right now. And so it is finally time to create this to-do API thing that we've been talking about. And it's also time to put your knowledge to the test with this entire thing. I'm going to head on over to VS Code real quick. And so, we'll start mapping ourselves out. Everybody should have their editor open along with the starter repository for that was given in the hack pack. And so before we do anything, let's actually try and run this, right? If we go ahead, I already have all of the dependencies installed. If you haven't done so already, make sure to clone it and obviously get all of your dependencies done with using the yarn command. If we run yarn run start right now, this is going to throw a pretty big error. Wait for it to compile. And we can see right here that, there are a bunch of different things. And this is going to be the first goal. We have to make this actually run. But before we do that, let's try to deconstruct this index.ts file real quick, right? What's going on here? How is the server actually, becoming reality? The first thing that we can see is, this build schema function. Like I said before, every GraphQL API has a bunch of different types that are associated with it. This essentially allows us to see all the different possibilities. Jackie, looks like your Docker is sneaking into my workshop. That's not very nice. So, our schema essentially needs to, have all these different types and all the different possibilities for what our API can do. And that's what this function imported from one of the libraries that we're going to be using, type GraphQL, is going to assist us with. Type GraphQL essentially allows us to, take a bunch of different TypeScript classes, right? Essentially write GraphQL as code and compile them into, GraphQL schema definition language. And so, the schema will actually contain both all the different types along with the resolver functions that are associated with all of them. And, in this case, we're not having any form of like on the fly type validation. So when we actually build a schema, we're not going and, mapping through all of them. That's just for the sake of time. Don't worry about it too much. And so obviously I have a little bit of a to-do here because this is the thing that's throwing our error, right? We have to actually supply resolvers so the GraphQL can understand what data to resolve. And then that schema, which is executed like concurrently, gets passed into this little server. Apollo server, again, is essentially just your, your instance of a, of your GraphQL API, right? We pass in schema, we pass in, the fact that we want introspection and our playground to be there, and we passed in this little context function. Context it essentially just passes around different values from place to place, right? It essentially allows you to forward things like HTTP headers, right? And so let's get started actually building this. And just for the record, we are most likely not going to be able to build through this entire thing. So it's worth noting that this entire big section is already up on GitHub. If you want to, you can scroll through all the different branches to really get a feel for how GraphQL APIs evolve over time and how we can actually start to move and build out this entire thing. For now, though, let's get started. The first thing we'll do is define an interface for what we want, a GraphQL or for what we want a to-do to look like. In this case, we can start typing in, interface I to do, right? And this is, again, in model/index.ts. And we can literally just specify here that, we want an ID on our object type. We want that to be a form or take the form of string. We want there to be a title that's associated with it. Again, this should have the type of string. And then we need a completion parameter. Again with a type of Boolean, because obviously you can't really represent true or false as a 1 or 0. That's not that's not really how we roll with client side things. If you're low level, that might work well for you, but I like to keep my types as verbose as possible. And so, after that, we can go ahead and add in a description property. This is optional, but I think it's pretty cool. So we can add in description with a type annotation of string. Now, this again is not going to allow us to run because an interface definition on its own won't actually do anything. If we open up our terminal again and run yarn run start, this still isn't going to build, right? And this is because we haven't actually defined anything that can be fed into our GraphQL start function, right? Let's exit out of that real quick. And let's start creating, our GraphQL types. More specifically, let's start creating TypeScript types that can be mapped over to GraphQL using the type GraphQL library. We're going to have to instantiate a TypeScript class. We can call this to do, and it has to implement the I to do interface that we just described. We can, open our, we can open this class and start writing out all the different things. If you're using VS Code like I am, you are a very good developer. And also, they have this really cool little function. I'm pretty sure WebStorm has this as well. But you can go ahead and click on implement interface I to do. which automatically gives us all the different properties that we already need, right? That is all done through their type inference stuff. We can also define a constructor for this class. If we just type in constructor, I'm going to use their autocomplete. Let's say that we want to create let's say that we want to create an instance of a to-do based off of just a plain JSON object that implements iToDo. Well, this constructor function is going to take in some form of a to-do. This has a type annotation of iToDo. And then we can use object.assign, which essentially just assigns all the different properties of a given source to a specific target. Because we're assigning to this, right, we want an implement, or we want our instance of to-do to have all the different properties of iToDo. We can assign, this to to-do. So that's great and all, but this still isn't going to work. We have to link this class up with type GraphQL so that it can actually start compiling this into real GraphQL schema definition language. We can start to do that by adding what's known as decorators. Decorators are what type GraphQL uses to understand what needs to be sent over to its GraphQL compiler for actual compilation into SDL. Remember, all this is being done on the server side. The first thing that we'll do is define the fact that this is an object type. Remember, object types are things that are similar to classes, right? And so when we have this object type, remember, you always have to add in your imports. Otherwise, it's not going to be able to see where this object type decorator is coming from. And so after we have this object type, we can start annotating each of these different fields. Pretty much everything that we want to get sent over to the GraphQL server for compilation, we have to mark with a specific type GraphQL decorator. In this case, we can go ahead and mark this with the @field decorator, right? Each of these takes in their own type annotation, which comes in the form of a function. We can say that this field will accept some form of a Boolean, right? Note the capitalization over here. Description will take in a field called string, and then we can copy and paste that for everything except for ID. In GraphQL, we want everything to be as secure as possible. And so they expose something, or a special kind of scalar type, called an ID. I said before that it is pretty similar to the way that strings work, but that's only on the surface. Under the hood, IDs are actually treated very, very differently, because inherently we suppose that they need to be as encrypted and as secure as possible. And so there's actually some clever algorithmic work that keeps that hidden from normal servers. And so instead of using the string ID over here, because we want this attribute to be compiled with the ID class, we can add that in our type annotation to field. So far your file should look something like this. And this isn't going to compile because while we've actually defined our to-do class, we haven't exported it and we haven't imported it back into our our big index file. So the first thing that we can do is export both of these objects that we've just written, both the interface and the class, and then we can start writing what are known as resolvers. Remember, models on their own will not do anything when we supply this to type GraphQL, right? Just having a server-side schema isn't going to do anything if you don't have any data to resolve this with. And so we can start writing out our resolvers in the index.ts file, right? Keep in mind, the specific file structure that we're using. Our models are defined in index.ts, but our resolvers, the places where we can actually get data from, are defined in resolvers/index.ts. I'm actually going to head back over here just so that anybody that didn't really get a chance to, see all of this at the same time that I did, to type all of this back out into their own file. Yeah, so far we have just defined an interface for what, the basic shape of what a to-do should look like. And we actually started writing out, the official implementation of a to-do that will get sent over to, to the GraphQL server for compilation. All right, so you should have finished writing out all of these different models out by now. We've also created a constructor. And so now we're going to go ahead and start defining what all the different getters are going to be. We're going to start defining the data resolutions. The first thing that we're going to need is mock test data. What might this look like? Well, we can try to model a database by literally just thinking of a JavaScript object, right? We can go ahead and create a const declaration. This is going to be a constant thing, right? Constant called data, which has a very specific type structure, right? We want we want this to look sort of like a document database. We have a specific ID, and that's associated with some object, like along with it, right? And so in this case, we're trying to define a record, right? We want this to be queryable by a specific string, right? This string is going to be the ID, and so we don't need to include that in the actual object that it's associated with. We can go ahead and use the omit, the omit syntax for that. We want to take out every single key. We want to use every single key here for each document of I to do. And then everything in that except for the ID parameter, because that's where we're going to be querying this entire data structure with. And so when you type in ID, this has been completed, but we're going to have another type error, right? We need an expression on the other end of this. And so we can use curly braces to define, an actual object, or in Python's case, if you're coming from that language, a dictionary. We can start to define our test data like this. We can just type in a random ID, something like that, and then create a colon, and then another object in between. Because remember, the opposite side, which is the value of this, has to conform to everything that I to do has, everything except for ID. And so, this is going to, again, throw another type error because we're missing the title, description, and completion properties off of this other object. And so let's go ahead and add those in right now. I'm just going to type in some stupid stuff. Feel free to, none of this is actually specific to, this project itself. Feel free to type in whatever you want. Description can be that, and for completion, let's say that this is false. Now from here, we want to maybe make this data a little bit more substantial. So feel free to copy that. Make sure to add in all of your different commas, and then update the ID so that they are distinct from each other. So now what? Well, we need to start defining our resolvers, right? We have this data, we have all of our different models, and all of that's going to be compiled over to GraphQL. Now we just need to figure out ways for the actual user to interact with it. The first thing that we're going to do is create a class called query resolver. And this is essentially just going to be standalone. It doesn't conform to any specific interface or protocol. And then we can start defining our functions purely from TypeScript. If we want to say that we want to get all the different to-dos, we can define a public, function called to-dos on here that will essentially just return, an array of objects that implement the I-to-do interface, right? And so what now? Well, this is going to get compiled over to GraphQL soon. So, we want to add in some decorators at the very end of it. But right now, we actually need to just write in logic in TypeScript. We want some way to map over this entire data object and transpose it into an array of objects that implement I-to-do. And so we can actually just use some really interesting, clever little, we can just use some interesting functional, constructs here. We're actually going to be able to do this in one line specifically. We can use the return thing to literally return it in one line, and then say that we want to map over this entire object. Well, we can use object.entries. This is a static method. Keep that in mind. Of a specific object. In this case, we want to map over data. And this is going to give us back, let's actually take a look at the signature of this. This is actually going to give us back an array of things that are an array of I-to-dos. And so we can map over all of this, right? And then start to destructure things with it. We want to say that this is an ID, right? And so the way that this value is being given to us is kind of like a tuple, right? The first value that it gives is the value of the key, and then the second value is of the second value that it gives in the tuple is of the value specifically. So obviously, if that all just sounded like a bunch of mumbo jumbo to you, don't worry about it. It's all just high level TypeScript stuff anyways. So we're going to destructure that. Just follow my lead. We're going to take out the ID from this tuple, and we're going to also take out the actual value. And then from here, because we want to return one specific ID, we're going to be, again, this object has to conform to the I2Do interface that we defined earlier. We can use the ID as its own, and then we can use spread syntax to sort of give us a feel for, to sort of map over all of the other values in this case. And so, again, we can start annotating our different things because we want this to compile back to GraphQL. The first thing we'll do is mark this entire class as a resolver. To see if we, I did not import that correctly. Now, keep in mind that all of this, it is very, VS Code's autocomplete is very finicky. So if you end up running into any errors, feel free to put that into the chat and we'll attack them later on. I'm actually going to change around this, this import from DNS to type GraphQL because I don't want things to break on the fly. And then we can mark this public function as a query. And this is going to return, yet again, we need another type annotation function. This is going to return an array of I2Dos. The syntax between all of these is a little bit different. And we're actually going to run into an issue here. This doesn't actually have anything to do with, whether or not we're including this query resolver in our actual function or in our actual build schema function or not. But it's actually due to the fact that we're not returning anything that GraphQL considers an actual type here. We're just returning plain JSON objects, when in reality, we have to return the class that we defined earlier called to-do, which will compile to GraphQL. The interface is just a TypeScript construct. It doesn't do anything really significant. So we're actually going to have to change around the type annotations of this a little bit. We have to replace every form of to-do, or I2Do, sorry, with just the regular to-do class. Over here in the other type annotation, let's see if our imports are correct. Let's remove that a little bit. And this should be pretty good to go, right? All of our type annotations are done. All of our decorators are finished. We can be sure that this is going to compile straight to GraphQL. All that's left is for us to include this in the different resolvers array. And so from here, we're going to have to type in query resolver. Looks like I forgot to type in export. Save that file again. Type in query resolver. Hit tab, and you should get your autocomplete, finishing everything for you, right? And in this case, query resolver is imported from, the local resolver module folder. When we save this, and we try running, yarn run start again, this should work just fine. If not, it's time for some live debugging. And there we go. We got our success message saying, the to-do server has started. Let's just head on over to the Brave browser. Well, my web browser actually. Then let's open up, the localhost server that this is running on. In this case, I'm expecting this to run on 5555. In your case, though, it'll probably run on localhost localhost 3000. And we can see right from here that we can start writing out our query, right? Let me just zoom in real quick so that you guys can see. And yet again, you can use your introspection techniques because this is a perfectly valid GraphQL API. We can just name this query because I'm lazy. And then we can start typing in all of our different things. We can introspect the to-dos object a little bit further. And we can see that it returns a non-nullable to-do and a non-nullable array, right? If we run to-dos right here, we can say, hey, let's query on all of the IDs, all the different titles. And if we run that, we get everything back. And so, that's about all that we have time for right now. But yet again, I'm going to be active for about the next half hour on here. And of course, you can see all the different supplementary resources and all the ways that you can extend this out into a real functioning GraphQL API, with all the different features that we discussed in the GraphQL, to-do repository that is in your hack fact from earlier. And so, that being said, thank you guys so much. GraphQL has been a pretty big part of my life ever since I first discovered it a couple of years ago. And this has been a long time coming. Thank you guys so much for having me. I'm Rishi Kotari, and once again, you can contact me anywhere at Rishiosaur or on Discord, where I'm always hanging out on the Hack the North server. Thank you so much. All right. Anyways, so it is very late at night, and so I brought my elephant companion along with me. If you guys have any last minute questions, feel free to ask, and then we'll be able to help you out. Thank you guys so much. What VS Code theme? Very good question. Let's actually take a look. Most of the time, I like using like theme packs. In this case, my current favorite is called Bearded Theme. It's the purple variant. I really like it. Thank you. 2 questions. So most of the time, if we're using a GraphQL library, we won't need to worry about writing the queries and mutations as strings on the front end. Also, are there other best practices we should know about? All right, so let's break that question down a little bit further. The first bit, if we're using a GraphQL library, we won't need to worry about writing the queries and mutations as strings on front end. No, because in most cases, the actual serialization of your GraphQL query will all completely be handled by that library that you're using, right? I would open up and show you another example of this right now, but I don't think we have time for that. And then the second bit, okay, TLDR for the first one, you don't really need to, you don't need to worry about serializing your queries itself. That should all be handled for you by your library. And if you aren't using, and if your library doesn't do that, more likely than not, it is a terrible library. Are there any other best practices that we should know about? Surprisingly, that would actually be a really good question if this was a REST workshop. GraphQL is great because everything within it is a best practice already. Everything from the way that you define queries to pagination structures, for instance, right? There is possibly no way to go wrong and write a bad GraphQL API because everything is automatically type defined. Everything is strongly typed. It's self-documenting. There are loads of different resources out there for creating these sorts of things. It's pretty much impossible to write a GraphQL API that's unusable, right? Unless, of course, you massively mess up the the programming of it. But that is something that can be easily remedied. And so TLDR, no, there aren't too many other really, really big best practices, right? Obviously, there are tons of maybe thousands of smaller, more medium-sized ones, but those all vary on the developer to developer. It's almost like asking an Angular developer, if you're coming from a React background, hey, are there any best practices for web development? And it's like, they're going to have a very different answer because everything in web development specifically is already a best practice in and of itself. And so, the only big differences between, different, big development practices are purely on the basis of the developer. How do we use the query variables tab at the bottom of the Apollo playground? Yeah, so query variables essentially allow you to sort of modify your query a little bit to, they allow you to modify your query using your actual programming language of choice, right? Let me just screen share yet again. All right, so let's head back over to g.rishi.cx. In this case, let's say that we don't want this ID over here to be 27 all the time, right? Because in most cases, this isn't actually going to be a string when we're using it, in an actual, front-end library or something, right? We're going to need a way to extract this out and supply an external value into it. And so the first thing that we're going to do here is say that, we want to supply a query variable. All query variables have to start with a $sign, just like in SCSS or something. Then we can say that that has to be of, that has to be named ID, and that has to take in an ID, a non-nullable ID, as its type, and then we can supply that as our just as our value for this for this ID. And obviously, wherever you're actually using a scalar value in arguments, you can use a query variable. If we try running this, we're going to get an error because we haven't actually defined the value of $ID. And so we can head on over to the query variable section and define a JSON map. In this case, we can say that we want ID to be equivalent to the value 27, right? And when we run that, we'll be all good. And just as in just in the same way that arguments can be any scalar value, including object types that are literally defined. Query variables can also be as dynamic. GraphQL can handle caching for me? Yeah, surprisingly it can. One of Apollo's really big strengths is the fact that there are a bunch of different extensions out there. And so while GraphQL itself can handle caching, there are a lot of different extensions that'll handle that for you, right? For instance, if you're writing a real-time GraphQL API, there's this one really cool thing that'll allow you to store your cache in Redis. If you have all of your different mutations coming at you at once, you can store that sort of in a in a bunch of different keys and values automatically, and it'll retrieve them for you server side. So yeah, it is very, very cool, and that's one of the reasons that Apollo is so powerful, because this massive ecosystem of extensions, right? It's the de facto for GraphQL APIs and TypeScript and Node. Anyways, I actually wanted your guys' advice on something, if you're still there. I've been wanting to give this elephant a name for quite some time. Do you guys have any ideas? Let's see. Bob. That's a very good name. Any others? Palindromes usually make for very interesting names. Node. Well, I mean, he does have a green tag, so yeah, I guess that could work. Ideally, though, I would not like my elephant to be insecure. Rafi. Edon. Pablo. Not too sure my elephant is too good of a painter, though. Would Pablo really be that good of a name? And Edon. Graphy. I don't know about you, but he did like this. Graphy could work, I suppose. Not too sure if that would work entirely well, considering the fact that I can't really get any data out of him. He's not exactly sentient. Postgres. Hey, that's a very interesting concept. I will keep that in mind. Yeah, for sure. The actual naming convention behind Apollo is very interesting. They actually just named it after the astronaut missions of the '60s, because they were a pioneering force in the space race for the United States, and the Apollo project for GraphQL is the pioneering project for GraphQL infrastructure in TypeScript and Node. Postgres is a very good name, though. I like that database a lot. That's my go-to. Yeah, I mean, any other legit questions aside from naming my elephant? What you guys think of the workshop? Heck yeah. Yeah, I mean, I like to think that hackathon workshops are usually a little bit uptight, especially when you know, like especially when it's this late at night. Like hopefully you guys could learn a lot in the beginning, and then towards the end got a little bit of fun coding practice. Thanks, Nicholas. Yeah. Glad you learned something new. Yeah, I mean, you guys got any plans for tomorrow? Say, I'm not too sure what the weather here in Brampton's going to be like, but here it's going to be pretty sunny. Wait, Withvik, are you in high school too? Which one? Oh, sweet. Yeah, I actually forgot that Zoom University was on right now. Yeah, I'm in grade 10 at Turner, or well, Turner Fenton Secondary. Sorry, I forgot. Not everybody comes from Brampton. Yeah. So it's illegal in Canada. In winter, like a lot of people think that Canadian winter is amazing and all. Like it actually sucks a lot. Seriously, like half the time that it's not even proper snow. It's just like slush because it's always been raining half the time, and the sun comes out, and then the sun it just melts all the different snow, and yeah, it doesn't really make for a very good experience. I would not recommend it. I think Montreal has much better snow though. Yeah, London. I'm sure that London would have much worse weather than us, but I don't think they actually have very low quality snow like we do. Actually, yeah, I think that ours is a little bit worse because there's two ways that snow can go. If that slush doesn't really clear out, it'll turn into black ice, and then you now have an extremely slippery surface, which you can crack your head on, as I did when I was like 6. So yeah, really not fun. Come to Waterloo. Yeah, I mean, hopefully if I get in a couple of years. Let's actually take a look at how our YouTube live is doing. I haven't been on there in a while. I'm not too sure about that. Harvard is quite a long shot. Yeah, looks like we have 15 people. Really appreciate you guys taking the time out and being here. Yeah. Any other questions about GraphQL? Feel free to put them in the chat. I always thought GraphQL would mean we graphs. Surprisingly, it actually did come it actually originated from this idea of data graphs, but not really like graphs in the chart sense. It always comes from some form of obscure math theory sense for some reason. But yeah, graph theory is where this was derived from. Facebook actually used to store their entire database in like a graph database, and that makes sense, right? When you have all these different users and have to follow each other, and you have to have all these different relationships, it gets really tedious to store it in something like a relational database, right? Because now you have second order of magnitude connections, right? You have to represent all the different connections between every single user twice over, and you have to represent that for every other user. And so, it really gets pretty tedious. And so they needed a way to efficiently, query over an entire data literal graph, right? And so GraphQL ended up being a way for them to do that, right? You could really easily traverse all these different objects, right? As I said before, the object types in GraphQL can be as nested and as deeply nested as you want. And in fact, they actually came out with a specification for things like this. It's called Relay. I'm actually going to send a link to that in the chat. Very interesting. This is actually an alternate. Well, it's a build on of the big classical GraphQL server specification. Relay just builds on that to supply really interesting things like edges and nodes. Really, just what things like Facebook use for traversing actual data graphs. That Relay was a React thing. Oh, Relay is actually just straight up a GraphQL project. They have both a server specification and they have both a server specification and a React client library. Maybe I'm confusing something else. Yeah. All right. So it looks like the chats in both the YouTube Live and like the Hop-In are starting to die down. So in the interest of keeping our wonderful organizers, hi there. If you haven't already said hi to them, feel free to say hi right now. And our amazing mentors, once again, thank you so much to Nicholas and Eamon. Like I'm going to be logging off right now. And yeah, once again, thank you guys so much for coming out. Hopefully you could learn something interesting. Hopefully you had a little bit of fun. And hopefully you smiled and laughed a little bit, right? I think we built something pretty cool overall. And yeah, once again, thank you so much for coming out. Yeah, anytime. And yeah, of course, if you guys have any other questions, I'm always going to be active on Discord. Yeah, feel free to log off if you don't have any other questions. That's it from me. All right, fantastic. I'm going to go ahead and log off now. Yeah, once again, thank you so much. Yeah, I should probably link my Discord, but again, that's all on the syllabus and the hackback. You can always find it there. And if not, I'm always active in any of like the public channels. So yeah, I'll see you guys later, and hopefully, I see you on the podium for Hack the North. Bye-bye.